All right, so we're going to talk about section 11.1 today, geometric sequences. We did arithmetic sequences in the past. Some of you might remember those with fond memories. All right, so we are going to have, let's get our definition down first. A geometric sequence is a series of numbers with a common ratio that we will label R. Now, you should have this note sheet and be filling this out with me. So make sure you locate that either in your note sheets tab if you're from one school, or you're in Educate with the other school. So let's see here. So let's talk about how to use this. So this is a geometric sequence right here. So let's just kind of look at that for a minute. I'm sure some of you might already be seeing a pattern. And the pattern is that when you go to this one, we're multiplying it by 4. We multiply by 4. We multiply by 4. Okay? Now let's say we didn't see that. Let's say we needed to figure it out, and it's more difficult, more like one down here where it's not quite as easy to see. What you do is you take any of these numbers to get the R, the ratio, and you divide it. I'll pick this 4. You divide it by the number previous. So the one that comes before 4 is 1. So my ratio is actually 4. 4 over 1 is 4. Now that would have worked anyway. I could have picked 16 over 4. It's also 4. Okay, so you will get that ratio when you do that. Now it asks you actually to find the next 3 terms in each. So you are going to use that ratio and you're going to continue on, and you'll get one of your answers, and you'll get another one of your answers, and you'll get another one of your answers by doing exactly the same thing. You're multiplying by your constant ratio. Okay, so you get your calculator out. 64 times 4 is 256. And 256 times 4 is 1024. I should have left these a little wider. And that times 4 is 4096. So my answer to this problem will be 256, 1024, and 4096. That is how I would write the answer. Okay, so let's take a look at this one then. Again, I said you have to get the ratio first. Some of you may see it, but with the negative it can get a little confusing. So let's figure it out. You do any term, and I like whole numbers, so I'm going to use those. You could do this one divided by this one, but I'm going to pick the 3 divided by the number previous to it. Okay, so just make sure you don't go the wrong direction. It's always the number divided by the one before it. Reduce it, and you get a negative 1/3. All right, so to get my next 3 numbers, I have to take that times a negative 1/3, and that times a negative 1/3, and that times a negative 1/3, and I'll get my 3 numbers. Okay, so I've got some fraction work here, so I'm going to do it down here. I've got negative 1/9 times a negative 1/3. Negative times negative is a positive, and 1 times 1 is 1. 9 times 3 is 27. So I get 1 over 27 there. Then I'm going to take that times a negative 1/3. Well, now I got a positive times a negative. So I'm going to get a negative for an answer. 1 times 1 is 1. And 27 times 3 is 81. And I've got my next one, negative 1 over 81. And I'm going to multiply that by a negative 1/3. And we go back to positive again, because a negative times a negative is a positive. 1 times 1 is 1, and 81 times 3 is 243. So my answers would be 1 over 27, comma, negative 1 over 81, comma, and 1 over 243. Excellent. Okay, so that's all fine and dandy when you know, they're small numbers and they're just asking you for these next ones. But what happens when we need to find like the 100th term? I don't need to find the 5th, 6th, and 7th. I want the 100th one. Well, that's going to be a long haul of multiplying, isn't it? So, of course, there's a formula. And this a sub n represents our nth term. A sub 1 is our first term. R is our ratio. And n is the n, whatever you have in place here, whatever term you're looking for. So let's just review what that means. When I go up to this problem, what is my a sub 1? It's whatever's in the first place. It means my first term, 1. My a sub 2 is 4. My a sub 3 is 16. And of course my a sub 4 is 64, and so on. Okay, so remember that this whole thing, a sub 1, represents whatever is in place of that first term. And there it's a 1. Okay, so when we look down here at this problem, it says the first term of the geometric sequence is 500. So the first term, that's a sub 1. So they gave us the first term. So I'm going to just put a little a sub 1 by it and circle it, because now I know in this formula right here, I have a sub 1. I have this number now. And it says the common ratio. Well, the common ratio were these things we were finding up here, but it's also in the formula right here, and they said that that's 0.2. So I've got my R. So I'm going to put a little R by that, so I can kind of keep track as we go. And it says, what is the 7th term? Okay, well, that is your n. So here we go. We've pretty much got everything to plug in here. So we start with a sub what? What term are we looking for? 7. A sub n. And we said the n was 7. Equals the a sub 1, our first term, 500. Now we need to put a parenthesis, and you'll have to do that all the time here. Okay, class? And the ratio is 0.2 raised to a power of n minus 1. Okay, so remember our n, we listed it right here. It was 7. So 7 minus 1 is 6. All we have left to do now is put it in our calculator, and you will absolutely need a calculator to do these. So I'm going to put this on here, hopefully, so you can see it. Let's get this over here so you can see our problem. When you are doing this, you need to locate on your calculator a y to the x button. So mine is right here. It's the main function of this key is y to the x. Yours may not be. Yours may be above it or a different color or a second, third. You need to figure that out. And we're going to first do the power first, because order of operations is power. So I'm going to do 0.2. I just put that in. Raised to the 6th power equals. There's my number. Now I'm going to multiply it by the 500. And there is my answer. A sub 7, the 7th term, is going to be 0.032. Okay? If you need help, replay that part with the calculator, because if you're not punching it in, obviously everything's going to come out wrong. All right, let's look at this now. We have that same formula, which I'm actually going to just rewrite at the top here so we can refer to it. A sub n equals a sub 1 r, to the n minus 1. And I am going to actually probably give you a list of formulas for this chapter, because there are quite a few of them. So just know that, but I would suggest possibly getting your own little note card, actually maybe even a bigger note card, and just kind of keeping track of these. So as you're working through the chapter, you can add them all onto one note card and have everything in one place. All right, so look at this. They give us our a sub 1. they give us our r, and they said find the sixth term. Also give you your n. So I want to find what class? A sub 6 is equal to a sub 1, which is 5. I don't put an a anymore. 5 is a sub 1. I take the a sub 1 out. I put the 5 in. Parentheses, don't forget your parentheses, raised to the n minus 1. Okay, remember this is my n minus 1. So 6 minus 1 is 5. I don't need a calculator for this one. That's nice. Because what's 2 to the 5th? Does anybody remember that? 32. So 5 times 32, class. Anybody know? That's right. 160. And we're done. Okay, so that's the first step. Well, it's kind of the main thing we're doing this whole chapter. Here's another one. When we look at this, what is the 9th term of the sequence? So we have to get all those values up here. I'll slide that back down. Okay, so we know 9th, that's your n. Okay, so I'm looking for a sub n. I can write that down. Now, what would a sub 1 be? It's your first term. It's your 2. And what would your r be? Do you remember how we figured out r on the other side? We took any term and divided by the 1 just before it. So I'm going to take my smaller. I have negative 6 divided by the 2 equals a negative 3. So we know our r now. It's negative 3. And I think that's all we need. So let's plug them in. A sub 1 is 2 times parenthesis. The r is a negative 3, and that's why we need the parenthesis, because otherwise you're going to start doing 2 minus 3. Raised to the n. Oops, I didn't put this in here. This is a sub 9, isn't it, class? Let's see, write that out. A sub 9 to the n minus 1. So 9 minus 1 is 8. So when you do this, let's get this so you can see it again. Okay, so it was negative 3 raised to the, what was it? 8. 8 equals that. Now I will multiply that by 2 times 2 equals. Okay, the parentheses are important because a negative 2 to the 12th is not the same as that. Because without the parenthesis, this negative would stay in the front. And what is 2 to the 12th? 4,096. And when the negative's inside, that means you're multiplying negative 2 times negative 2 times negative 2. And since it's an even number up here, you're going to get a positive. Okay, so those are not equal. So you just need to make sure you're aware of that and be careful and make sure you put your parentheses around your things. All right, so let's wrap this up with our last problem. A ball is dropped from a tower. The table shows the heights of the ball's bounces, which form a geometric sequence. What's the height of the 6th bounce? All right, well, let's get our formula down. Okay. And now we need to know which one. We want the 6th one, so that's our n. So we want a sub 6. And what is a sub 1? It is our first bounce height, right here. That is our a sub 1. So I'll put that in there, 300, times parenthesis, our ratio. Okay, remember ratio. Ratio is taking a value and dividing it by the one previous. So it's 150 over 300, which comes out to a nice half, raised to the n minus 1. 6 minus 1 is 5. So we grab the calculator again, and 1/2 is the same as 0.5. So I'm just going to do that. Raised to the 5th power times 300. And I get 9.375 centimeters. That's how high that sixth bounce will be. Starts at 300, and as you know, slowly goes down, 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 down. Well, by the time you get to the sixth bounce, we're not getting very high off the ground anymore here. All right. Now, those of you that are such incredible students and are paying close attention, I've got an extra credit problem for you that is kind of fun. And if you do this and send it to me via email, I'll give you an extra point on today's homework. So send it to my email. This won't go into the OneNote. And here's the deal. I'm going to give you 1 cent on the first of 20 days. Each day you will receive twice the amount as the previous day or the day before. How much money would you get on the 20th day? Okay, so all you have to do, and guess what? Hint, 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 this is where this formula works. You can use this for the formula and tell me how much money in normal dollars and cents you would get. Don't tell me the number of pennies. I want to know dollars and cents on the 20th day. So the only requirements is that you email it to me, you use the formula, so write the formula, and then plug in the numbers so I can see it, and put the answer. So those aren't, so go ahead and do that on a piece of paper, take a little picture of it with your phone or whatever, and go ahead and send it to me via email. ksilva@stagnusschool.org. But I think most of you have my email. So, all right, class. Awesome. Can't wait to see your answers. I think you're going to be amazed at how much money you get on that 20th day. And then I'll let you know if you're right, too. Take care. God bless. Bye-bye.